Alright, this is 3-4 notes, writing exponential functions. Objective, you'll be able to write an exponential function given a word problem. So here's this one example of a word problem that we're going to be doing and working with. And we're going to practice this particular problem quite a bit, so we feel nice and comfortable. So it says a certain type of tulips plant is growing in a pond in such a way that the number of plants is growing exponentially. The number of plants, n, in the pond at time y is modeled by the function n parentheses y close parentheses equals a times b to the power of y, where a and b are constants and y is measured in months. The table shows the two values of the function. So we're looking at this table here, y's. So after the initial amount of months, 0, we know that there was 72 tulips. So that's where we're starting from. After 5 months, there's a total of, count how many zeros, there's 7,200,000 tulips in this garden. So after 5 months, it really grew. So this must be a big garden. After 6 months, well, it's e to the 7, so that's a really, really high number. We're talking maybe even a trillion, counting how many zeros. So anyway, we got to make an equation here. So it says write an equation that can be used to find the number of plants n in the pond at time y. Enter your answer in the space provided. So based on this chart that's given here, we got to write an equation. And obviously they give us some tools here to use online. So let's do that. So we know our initial, the time in the beginning. Let's see if I can make it bigger. Cool. We could get rid of that chart on the bottom. So in our chart here, we say our initial amount of tulips in the beginning is 72. So I know 72, we want to state we're starting off with 72 tulips. So to find out, we know we need an n of y is equal to 72 tulips. Now, 72 times the initial, anything to the power of 0, you know it turns into 1. So we don't know exactly what that b value is yet. But we know the initial amount is 72. So 72 times b to the power of 0, because remember the y is in that upper right hand corner from this equation. So I know that's where I'm going to put my 0, my y. So the result of 72 is equal to 72 times some number to the power of 0. So now I got to figure out what is that some number. How am I going to figure out what that b is? Well, figure out the b, that's really like our growth rate of how it's growing exponentially. So we know when y is 5, so instead of 0, we know our answer is going to be 7,200,000. So we're going to stick with our 72 times some number to the power of 5. We know that's equal to 7,200,000. So we made ourselves a little equation. Now we're going to solve for b. So we're going to divide both sides by 72. Hopefully you guys can see that work there on the side. So we divide both sides by 72. So we're going to get b to the 5th is equal to 100,000. And then we got to take the 5th root, because the 5th root is the opposite of b to the 5th. So you take the 5th root of 100,000, we put that in the calculator. I bet that comes out to a nice pretty 10, but we'll quadruple check. So we do 5. Then we're going to hit the math button. We're going to scroll down to number 5. So it's an x square root. So that's the 5th square root of 100,000. Hit enter on a calculator and we get 10. So b is equal to 10. Don't worry, we're going to do a couple of these. So I know this is tough. So our B is 10. So our answer is 72 times 10 to the power of 0, or to the power of y, because that 0 is just standard for that beginning one. So the power of y. So our answer is D for dog. That's our equation. Let's see if we can squeeze one more in before the battery dies here on the on the camera here. So we got a certain type of daisies. Plant is growing in a pond in such a way. Number of plants is growing exponentially. We have that same formula set up. N of G is equal to A times B to the power of G. And our goal here is write an equation. So we know, looking at our initial, we start off with 101. So we know N of G is equal to 101 times some number B to the power of 0. So 101 is equal to 101 times B to the power of 0. So we know that's true. That's our first one. Our second data point says 4,949 is equal to 101, because that's our initial, our starting amount of daisies, times our B, and then our power of G is 2, so it would be B squared. Now our goal here now is to solve for B. So we're going to divide both sides by 101. So 4949 divided by 101 is equal to 49. So 49 is equal to B squared. You take the square root to both sides, because that's the opposite of squared, and you're going to get B is equal to 7. So my answer would be N of G is equal to 101 times 7 to the power of G. So my answer here would be letter C. Green and green. Let's see. See if we can get lucky to do even one more. So we got tulips here. So here's our chart. We got that same formula set up. N of G is equal to A times B to the power of G. We look at our initial. At the 0, the beginning of the experiment is 125 tulips. So we do N of G